Hi, I'm Sandy Montgomery, the project manager at Marshall Space Flight Center for Laser Power Beaming. Today is October 17, 1994, and I want to show you a few of the new things that we're doing in the PAMELA test bed. Here in front of me is an aberrator plate. It simulates the atmosphere for us when we're in the laboratory. It's a common piece of plexiglass, and we spin it with an electric motor at about 10 revolutions per minute. There are pockets of air at different altitudes in our atmosphere that distort the image of a star as seen by a telescope on the ground. This device simulates that same distortion in the laboratory. Here in the PAMELA test bed, small faults in this plexiglass will randomly distort the image of an artificial star created by our interferometer, in much the same way that the atmosphere would if we were set up in an observatory rather than a laboratory. The major difference is that our aberrators creating distortions that are more severe than the atmosphere, both spatially and temporally. We've put a camera in the optical train of the PAMELA test bed so you can see what an astronomer would see using a telescope. Here is our artificial star before we turn on the aberrator. This shows we've got good initial alignment of all PAMELA segments. Actually, we verify this using our interferometer, as shown in this image. The corduroy pattern extending all the way across the aperture shows that we have very precise tip-tilt alignment. Let's look back at our artificial star as we start the aberrator turning. See how the atmosphere throws the image into disarray? Instead of 36 sharp individual star images stacked on top of each other and steady in the middle of field of view, as we would expect, we have many smaller fuzzy images flying all over the place. This is the condition that has confounded ground astronomers since the invention of the telescope. We'll now initiate the PAMELA controller and compensate for the distortions of the moving aberrator wheel. And there you are. We can already see that the concept of an active segmented telescope like PAMELA is proven. This technology will provide a capability for the current generation of astronomers that was only dreamt of by their predecessors. And it provides a vital link in the chain of advancements needed to make laser power beaming a reality.